Mitadru Datta from IITkgp, and in this video we are going to talk about the pandas library. We will start from the basics. 2 videos we will learn about this library, and we will see how useful this library is in data handling and manipulations. Almost all SQL like functions we can perform using this library. And then in my next to next video I will be talking about the mathematics associated with machine learning before going into the main machine learning algorithms. So let's get started. So guys, I am in my presentation screen sharing mode, and so let's start with today's video. So, introduction to pandas. It is the primary module used in machine learning for manipulation of data. It helps to handle and alter a large amount of data conveniently. As we progress through this library, you will find that it has many functions similar to SQL. It can perform almost all the functions similar to SQL. It can also cover some aspects which even you have learned in NumPy. Even NumPy can do those. So the ways of import, basically we use import pandas, but to use them we need to write pandas dot something. So we will import it as import pandas as PD, so that we can every time we need to import the library we can write pd dot something and then our function. So first function we will start with is the most important one, read function. So first we import pandas, then we assign our file handle as x, pd dot read underscore csv. This is a function which allows us to import csv files in our x, which is the file handle. Using x we will do further manipulation of data. You must note that the path may be a simple system directory or may even be an internet link. If you find something CSV file on the internet, you can simply copy paste the path here. If you are using a Jupyter and those your terminal is must also be connected with the internet, then if you do print type of x, it will give you pandas data frame. Note that the file does not always need to be CSV. This is very important. Like we generally use CSV files for machine learning, but the files may be HTML file or maybe other files too. So now you must note that in this function the first row is automatically taken as the column header by default. So suppose we would be talking in this video about the iris dataset. So let me introduce to you about what is iris dataset actually. It is a dataset which contains 5 columns and 150 rows. So if you copy paste the path of iris dataset into this read.csv and you do nothing else, then Python will automatically give the column header as the first row. Now let's see what this means actually. You can see the table over there. You can see this is the first row. If I this thing, you can see the column headers are 0 1 2 3 4. This I did using some function. If I had not done it, Python by default takes the first row as the column header. The first row should have been the column header. So what to do to ensure that it does not happen? We can simply import pandas as PD and then we can write the file as we don't. Now if we don't want the first row to be taken as the header, we said header equals to none. That is, our now code will be x equal to pandas read underscore csv, enter the path of the file csv file here, comma, header equals to none. We need to set it, and then we will get the same header as row header and column header. The default value of n is 5. Note that there is also another useful function, x.head n. It shows the first n rows and the column header is not counted as a row. Number of rows will reduce to 149 if it was 150 earlier. So the default value of n is 5, that is x.head, and if we write nothing here, it will show the first 5 rows. So I will also show you what output does it give actually in the next slide. And let us see that there is also another function, x dot d types, you need to remember all these small things to master it. Like these things must be kept in your mind, because when you are handling a large data set, you may want to know what column, what is the data type of each column, and according to that you will be requiring to perform the manipulation of that. So x dot head, as I told you, will give you the first 5 rows as the output, where x is the iris dataset. So let me also tell you about what actually is this iris dataset I am talking about. So it is a dataset which contains 5 rows and 150 rows and 5 columns. The columns are, the first is petal length, then it is petal width, then it is sepal length, then it is sepal width, and 4 is the class. Class can be of 3 types: iris cetrosa, iris virginica, iris versicolor. These are, and now why I am referring to this particular data set. In machine learning used by most learners, this is the most useful data set that you will see, and using it you can learn all the algorithms of machine learning very easily. And this is a very famous data set used by almost all beginners in the first step towards their journey of machine learning. So you see what is the output of print x dot d types. As I told you in my previous slide, it will be something like this. The first 4 columns are float, and the fourth is an object, and the data type is also an object. So now let us see how we can change the column headers, which was earlier 0, 1, 2 and all. So if we do x dot columns, it will tell you what the current column headers are. X dot columns equal to sepal length, sepal width, petal width, and the fifth one is the flower type. This will change the column headers to the specified values. Now we will have the column header as SL, SW, PL, PW and flower type. Now there is also a describe function, which is a good way to get some statistics around the data. By default it includes all the columns with numeric data. So print x dot describe the result, it exclude the nan entries. If we want to include all the columns for the result, then we will use x dot describe include equals to all. So what is nan entries? Nan means null, which does not have any value in the data set. So if we do x dot describe, it always excludes the nan entries in the output. So if we also want to show the null entries and want to know what the entire table is, we can just do x dot describe include equals to all. You can see it gives us some very useful statistics. It gives us count. I told you the number of rows is 150. It gives you whether it is unique or not. No sepal length is unique with each other, therefore it gives us null. And how many unique flower types are there? 3. I told you about 3 flower types: iris cetrosa, virginica and versicolor. So the mean, standard deviation and minimum value are also there. So it is not the end of this table. Actually there was more. I could not copy paste the entire thing. So it gives us a lot of useful statistics. So this describe function is also very useful while our data handling. So let us see some more functions. Accessing a particular column. So x dot column name or x of within single quotes column names lets you access a particular column. X like x dot sl, or we can write it in this way. We saw that the sl is the sepal length. It is the name of the column, and you can also call describe on a particular column too. You can write like x dot sl dot describe. Earlier describe was used for describing the whole table, but here you can also do to describe one particular column if you are interested only about that. And then another is also like data frame dot end. Here x is the data frame, so there it should be x dot is null. Will give you a list of null entries. We can also use df data frame dot, you can also put x here, x dot is null dot sum, which gives us the count of the number of null entries in every column, like this function. it will give us how many null entries are there in each column. So let's learn about the ILOC function. It is very similar to the 2D accessing elements in NumPy, which we have learned in our previous video. So what is this actually? I had told you that the first argument will tell you how about what is the range of rows, and the next argument will tell you what is the range of column. So if nothing is we mention, then we are telling give me all the columns and give me starting first 0 1 2 3 till 3, 4 minus 1 it will go. So 0 1 2 3 are actually 4 rows, selecting the first 4 rows, selecting data for the first 4 rows and the first 2 columns. We can do like this. Nothing means starting from the beginning, and nothing in the end means starting ending at the end. Selecting data for the row 2 to 5 and columns for 1 to 3, you can do like this. You also know that 6 means 6 minus 1 till it will go. I have explained this types of function, ILOC type function in NumPy also. Now there is the drop function, which is used to delete a row from a dataset. X drop 0, basically this is the index number. No changes. If you do only this, you will see that no changes have been made, because drop function does not delete rows from the original data frame. This is very important, because it creates confusion at a later stage. Like it creates a copy of the data frame and returns the updated copy. So actually if you even do drop, you will see that nothing has changed in the actual table. So to make the changes visible in the original data frame, we need to pass in place equals to true argument. This ensures that the changes are made in the original data set. X.drop 0 index in place equals to true. Now we can also want like 4, 5 and 8, these index numbers if we want to delete. These are the rows, names of the rows, row header if you want to delete. We can use this 4, 5, 8, and you see those aren't there, and 0 also we had deleted, the 0th row that is also is in there. And if you do head 10, the first 10 output will be shown. So yeah, that's all from this video. In the next video we'll be talking more on this, some more stuffs about pandas library. Thank you.
So yeah, that's all from this video. In the next video we will be learning more about this library, some more Python function, and I will provide you my notes, handwritten notes, which will be helpful for your reference. So yeah, that's all.